Let's start by looking at some extra ratio problems from the book, page 238. So a glass contains alcohol and water in the ratio 1:4. A second glass has the same quantity of liquid, but the ratio of alcohol to water is 2:3. If mixed together, what's the final alcohol to water ratio? Okay, so we need to consider the first glass, and the ratio in the first glass of alcohol to water, the alcohol shaded, is 1:4. So there's 5 parts in the glass, 1 part is alcohol and 4 parts are water. And in the second glass, which is the same size, same quantity of liquid, we consider the fact that again there's 5 parts, even though it's different ratios, 2:3. So in this case 2 parts are alcohol and the remaining 3 are water. So if we add the two glasses together, you can just visualize or picture one glass stacked on top of the other. Then what we have now is a taller glass with 10 parts, 5 from here and 5 from here. And 3 of those parts are the alcohols, they're represented here, the 3 parts. And the remaining 7 parts are the water. So the new ratio of the new mixture is 3:7. Question 21 then is on page 238, and that tells us that 1 full glass has vinegar and water in the ratio 1:3. Okay. Another full glass of twice the capacity of the first, so it's like one glass stacked on top of another. So there's the lower glass and there's the upper glass. Okay, because it's twice the capacity, so it's 2 times this of the first. Has vinegar to water ratio of 1:4. What is the new ratio if mixed together? Well, let's consider, we know this is 1:3, so we know there's 4 parts. 1 part is vinegar and the other 3 is water. And if we look at the taller glass, then it's twice the size. The ratio is 1:4, so we can have 5 parts up to halfway, where we've 1 vinegar and 4 water, and then the remaining half then 1 vinegar and 4 water. So we've 2 1:4s, if you like. That's the ratio we were given. Okay, but it's twice the size of this. That's why we've got two glasses to represent that. So if we add up our vinegars, it's 2 is to 8, and you can see that there's 2 shaded parts in that canister, and there's 8 unshaded, which represent the water. So what you have then, in fact, if you mix them together, and visually you can kind of stack one on top of the other so you can see what's going on, we have our 1:3 glass on the top, so that's 1 part vinegar, 3 water, and then we've our 2:8 section here. So if we add up our vinegars, we get 3, and if we add up our waters, we get 4 and 4 is 8, plus 3 is 11. Our new ratio of the mixture is 3:11. Now there's a question, question 22 in the book, and it's not a very nice question at all, but just give you an idea how to approach it, but really I think it's slightly beyond this course really. But anyway, a male punkyfish has 9 stripes, a female punkyfish has 8 stripes. I count 86 stripes in my tank. What is the ratio of male to female fish? So it's a very tricky one, but the way you would approach this is that you let x equal the number of male fish, y equal the number of female fish, and then you can set up this equation, it's a linear equation, that says that 9 times the number of male fish, so the 9 stripes, plus 8 times the number of female fish must be equal to 86 stripes. So we could find whatever this x and y values were, so that 9 times x plus 8 times y equals 86, then we'd know how many males and we'd know how many females. Okay, so how would you go about doing that? It's really not for this course, I think, at the moment anyway. Well, you have your linear equation, so you know that a plot of that gives us a line, straight line. So what you do is you rewrite the equation in the form y equals mx plus c. And then you could plot your graph, and you know that it intersects the y-axis, okay, at 10.75, and this is minus 1.125 for every unit index. That's the slope. So it just keeps coming down here, and actually you'll get to a point at 6.4 where this will be an integer, a whole number. They'll both be positive. You'll have, this is the x coordinate and the y coordinate, this is the male and this is the female. So 6 males to 4 females would work, and if you actually if you can reduce that to its simplest form, actually if you say 6 times 9 plus 4 times 8, that does equal to 86, so it holds true. But 6 is to 4 is 1, but we can reduce that further still to 3 is to 2 in its simplest form. And that is the ratio that you'd be looking at in the tank. 6 is to 4 or 3 is to 2. But that's a bit, I think that's a bit too tricky for this section of the course. Okay, let's look at time and timetables, and we'll just leap straight into an example here. A car journey began at 10:40 and finished at 13:25. If the car used 6 litres of petrol per hour at €1.65 per litre, how much did it all cost? Well, we have to find the length of the journey, and we do that by taking the initial time from the finish time. Now, we potentially have a problem here in that we've more minutes here than we have there. So when we have this situation, when we're trying to subtract more minutes from less minutes, then what we do is we reduce the hour by 1 and we add 60 to the 25 to give us 85. So now we've 12:85 minus 10:40, and that gives us 2 hours 45. Okay, that's 2 hours 45 minutes. So in terms of hours, then that's like 2 3/4 hours, or if you're in doubt, it's 2 plus 45 over 60, and that's equal to 2 and 3 over 4, which decimal is 2.75 hours. Okay, so if the time, so 6 litres, if it uses 6 litres of petrol per hour, how many litres did it use for this 2.75 hours? We just simply put your unknown litres under here, your 2.75 hours under your 1 hour, cross multiply, and you'll get x by 1 is equal to 6 by 2.75. That's 16.56 litres, 16.5 litres at €1.65 gives us an answer of €22.23. That's how much the journey cost. Okay, let's talk about speed, distance and time. Well, the formula for speed, and you'll know this from your science, speed equals distance over time. We can rewrite that as time equals distance over speed, or distance equals speed by time. And often we use Dad's silly triangle, DST, and you cover what you want to find. So if I want to find what distance is, I cover that up, and it's D is equal to what I see, S times T. And if I had D back there and I wanted T, I'd cover T. T is equal to D over S, and so on. So a train travels a journey of 210 kilometres in 2.5 hours. Find its average speed. Speed equals distance over time. Distance is 210 kilometres. Time is 2.5 hours. Speed is distance over time is 84 kilometres per hour. Second example. A motorist travelled 500 kilometres in 6 hours. Her average speed for the first 2 hours was 100 kilometres per hour. Find the average speed in kilometres per hour for the last 4 hours. So for the first 2 hours, she was doing 100 kilometres per hour. She did 2 hours, so she must have did 100 in the first hour and 100 in the second hour. So she travelled or covered 200 kilometres. Now she went a total distance of 500 in 6, and she took her 200 to do 2. So the remaining 4 hours she travelled 500 minus 2 is 300 kilometres. So the speed, average speed then in that last 4 hours must be equal to the distance 300 divided by the time 4, 75 kilometres per hour. So she went quite quickly for the first 2 hours, and then her speed reduced. Maybe she hit more traffic on the way.